Welcome to all. On behalf of Department of Statistics, Dr. B.R. Ambedkar Open University, normal distribution. Today with us two professors. One is Professor K. Sampath Kumar, HOD and Dean Faculty of Science, Telangana University, Nizamabad. Another professor is Professor N. Raju, HOD and Professor Guru Nanak Institutional Technical Campus, Hyderabad. Today we are going to explain what is the importance of normal distribution, what are the applications of normal distribution, what is the real life applications of normal distribution.
Now I am going to explain for student point of view, for a student understanding this concept. For that I am explain the working procedure and few example problems for understanding of the student.
Yes,
okay.
yes.
So working procedure for this normal distribution is normal to distributed values is okay. Let x be a normal variate with mean mu and standard deviation sigma. Already these two mu and sigma are what? Two parameters
of normal distribution.
Parameters of the normal distribution. Suppose we want to find the probability that a randomly selected value x will be lies between a and b. Okay. In that case, my probability, that is probability of a is less than x is less than b.
That is
Okay,
nothing but
my
area,
values are
that is nothing but area between
these
A
two
and B
particular
only.
a and b
normal
values.
distribution.
A and b values. For that, first step is convert x into standard normal variate by the formula z is equal to x minus mu by sigma.
That is called normalization.
Standard normal variate.
That is exchange to Z.
Yes,
Standardization of the data.
Standardization of the data, because x data is a big data.
Big
Now
data.
convert
Big
into
data. That is
normalization.
converted into normal data.
Yes,
we need to find out the smaller values. Then by making use of table, we should identify the standard tables are available with us, standard normal area tables. By making use of that standard tables, we can compare with our Z value. We find out the Z values. After that, we need to check the what is the chance, what is the probability of that values lies between these particular related problems.
Yes, sir.
Yeah, that step number 2 is coming to find the limits of Z corresponding to the limits of X. Okay.
So that
When
is
x is
standardized
equal to a,
values.
standardized, my data is converted into standardized form. When x is equal to a, then z is equal to what? A minus mu by sigma. This mu a is a variable here. Mu and sigma are standard values. In our question already these are the parameters given to us.
Yes.
Okay. When x is equal to b, then z becomes b minus mu by sigma. Okay, these are after converting the z. These values I can substitute in step number 3. My step number 3 is probability of a is less than x is less than b. For that, we need to find the probability values. That means probability of a minus mu by sigma is less than x is less than b minus mu by sigma. That values a minus mu according to our question is what? When it is our data is transformed to in terms of standard normal variate. Na?
Yes.
First one I can assume z1 and let us assume the second value is assumed to be z. My z values always lies between z1 and z2 only. After getting these z1 and z2 values, now from the table find the probability of z lies between z1 and z2. So making use of table, we should find the what is the value, what are the required information is required. Based on these z1, z2 values, we will get the solution to this particular probability.
That means we will get the area between the
Yes.
Z1 and Z2 in standard normal tables.
Yes, exactly. Now, what I said just now, how area properties used in while discussing the problems. I will going to explain few example problems here. So, application problems are normal distribution.
Right.
Yeah. First example problem is entry to Dr. B.R. Ambedkar Open University, Hyderabad is determined by a national level eligibility test. The scores in this test are normally distributed with mean of 500 and standard deviation of 100. Sai Pranati wants to be admitted in this university and she knows that she must score better than at least 70% of the students who took the test.
Okay.
Sai Pranati takes the test and scores 585. Will she be admitted in this university? This question is asking like this.
Yes.
So already we are tested, exam is conducted, we know the
Mean
Data.
mean and the data sets also we know that.
Yes,
Okay. How so whether she will get the admission in Dr. B.R. Ambedkar Open University or not.
Okay.
For that, So this data I would like to convert. I can apply my normal standard normal variate procedure. For that, I need to find the probability. How much chance she will get to get the admission in this university.
Yes, we are giving the only
Yeah,
chance, not exactly.
Not exactly. We are estimate forecasting. Probability tells about chance only.
Chance only,
Okay. So let x be a random variable that represents the scores. The scores are distributed normally.
Normal distribution.
So that means x follows n of mu comma sigma. Okay. Yeah. So n is equal to what here? 500. And standard deviation is given, that is why I put here sigma. Standard deviation value is only given to us. Okay. So that is why you can, otherwise generally we can take mu comma sigma square. But in our question they given standard deviation only. So I'll directly standard deviation given, that is why I use the symbol standard notation x follows n of mu comma sigma. So for that x follows n of 500 comma 100. The total area under normal curve represent the total number of students who took the national eligibility test.
Right.
So that means, so if we multiply these values of area under the curve by 100, we will obtain the percentage, generally this. Okay. Now, for our calculation point, what is the first step? My x value is transformed to z. I know the formula. What is the formula? Standard formula. Z is equal to x minus mu by sigma. So my x value is 585. This score is substituted in z. Z is equal to, in that case, Z is equal to what? 585 minus 500 by sigma. So after simplifying this value, so that means 85 by 100. Generally we will get 0.85.
Yes.
Okay. The proportion, that means P of students who scored below 585 is given by probability of area to the left of Z is equal to 0.85. How this I can explain the tabulated form also. So for that, from using the table I got this value. What is the using table from normal table?
Normal tables.
Standard normal. I can. So a student is can able to identify this thing. How to identify this normal table value? I will explain one in making use of this table also in this example. Okay. From table. How I get this table? I will show in next slide. Okay. What is the value here? We got it here 0.802.
So that person may get 80% chance for getting the admission in the Ambedkar Open.
Then how I will explain this thing in next slide. So now it looks like a which curve here? Bell shaped curve.
Right.
Z takes a values where to where here? Minus infinity to plus infinity. Z is equal to 0. My Z value is here falling under this side.
Right.
Here this is my Z value. My Z value is equal to how much here? 0.85. Okay, now you see. So looking up the standard normal table. These are the tables. Now just you check it. What is the area to the left of Z is equal to 0.85 in the standard normal variate? That is a question mark.
Yes.
Okay. Now how student is identified? You check the here vertically we have to go for 0.8. After point we can consider first number.
First number.
First digit only. What is the first digit here? 0.85 here. Here have you seen this in the now my value is Z is equal to 0.8 is in vertical. Now I can go for horizontally.
0.5.
So now horizontally what is the value? After not consider this 0.85. 0.05 here in this table. This intersection point. That intersection point is tells about value. The table. This is a way of a student can able to identify the table value. So horizontally and vertically. So these are the vertical values up to 3 only maximum value, because what is the maximum range here? 3 only table. Yeah. So this side we have taking the whatever the values is required for us. The intersection point horizontal and vertical value intersection point is provided as to table value. So in that case our total table value is 0.8023. So I will get the total area. Already just now I explained here. Total area is equal to this percentage into 100.
Yes.
I got this total area is 80%. Okay, 80.23%. Okay, so this is the way of. Therefore, probability of area to the left of Z is equal to 0.85 is equal to 0.823 into 100% is equal to 80.23%.
Yes.
So now I can say, I can conclude. Sai Pranati scored better than 80.23% of the student who took the national level eligibility test, and she will be admitted in the Dr. B.R. Ambedkar Open University. This is a chance.
The chance is
Chance is there.
Yeah, there
She
is a
scored.
70%. Yeah,
This is a score.
70% is the
Now we
deadline
have to
actually.
estimate. This is a deadline. So
Yes, sir.
she is getting the she got the better score.
Better score.
Better score.
Yeah.
Now she is able to join in this institution.
yes.
Yeah, that is one of the application problem. Similarly, I can explain one more example problem for better understanding the this area property. For a certain types of computers, the length time of between charges of battery is normally distributed with a mean of 50 hours and standard deviation of 15 hours. Mahalakshmi owns one of these computers and wants to know the probability that the length time will be between 50 hours and 70 hours.
Yes.
She is expected.
Yes, yes.
How much chance if she buy a computer?
Computer.
Okay. So now same thing. Let x be a which type of continuous random variable only this is.
Yes, yes.
Let x be a random variable that represents length time. Okay.
Yeah.
The
Already
length
assumed a
time.
normal
Yeah,
distribution. We can
So the
proceed
length
with
time
the
of the
same
distribution is normally distributed. So therefore my x follows what? Normal distribution n of mu comma sigma.
square.
So mean value is already given to us 50 and standard deviation is also given to us, that is 15. The standard normal variate formula already we know that. What is the standard normal variate? Z is equal to x minus mu by sigma. So now which value we need to find here? So we have to find probability of x lies between, what is the value? 50 to 70. So therefore my probability values, probability of 50 is less than x is less than 50 is equal to, then these values are transformed into Z, value. Convert into Z. When x is equal to 50, my lower limit value is what? 50.
50.
My maximum value is what? Upper limit value is 70. So when Z is equal to 50, then Z is equal to 50, my formula is this one. 50 minus 50 by 15, that is 0. Something by 0 is something by 0 by something is always 0. So that I can say Z1. Z1 is equal to 0, I can say. When x is equal to 70, my Z value is 1.33.
Yes.
So my x values are transformed in terms of Z1 and Z2. Therefore, probability of 50 less than x less than 70 is equal to probability of Z1 is less than Z less than 72. So what is your value? Z1 is 0 and so Z lies between 0 to 1.33. So the total area under this 0 to 1.33 curve value is 0. From table, already I shown the table, now to identify this table value, okay, that is 0.9082.
So that should be converted into probability of Z is less than
Yes.
Z2.
Yes.
So if it is Z1 is less than, Z is less than Z2,
Yes.
we are supposed to convert into the Z is less than Z1 and Z is less than Z2. Like that we are supposed to convert.
Yes,
and
sir.
then
What,
we
sir?
can go for
Yes,
the
yes, sir. So my
tables.
value is according to our question is, what is the chance here? Chance is there. How much chance is there? That is 0.908, as closer to 1. Yes. So the probability that Mahalakshmi computers has a length of time between 50 and 70 hours is equal to 0.9.
So 90% chance.
90% chance is there.
Yes.
So 90% chance.
Chances.
So one more important application is, sometimes already converted value is given to us.
Right. Okay.
Yes.
So two cases, sometimes we need to convert the data into standard form, otherwise sometimes standard form values are given to us. In that case, how to identify the area?
Right. Right.
Yeah.
But
So this is
earlier I
the
said
second
that like that
application.
we are
Yeah,
supposed
this is
to-
the second application.
Yes.
What is the second application here? Standard normal variate application problems.
Yes. Yes.
Okay. If Z is a standard normal variate, find the probability. What is the first one? To the left of Z is equal to minus 1.78. To the left of Z is equal to minus 1.48. Students may be confused with this minus symbol
negative values.
many number of times.
Right.
So I clearly explained with using the diagrammatic representation in that case also.
That is symmetric distribution.
Yeah,
Whatever area minus into 0, this also equals 0 to infinite.
Yes.
The 0.5 to 0.5.
Yeah. In that case, I
area
will
should
give
be
the one
same,
more area. So that is why we can. This is the one different case.
Yes, sir.
Okay. If I explain like this, maybe a student maybe understand the concept.
Right.
That is why
So
I can
maximum
choose
students
this.
are confused.
Yeah,
with this,
confused in that case. That is why I can choose this problem.
Yes.
Right.
Okay. So I'll explain this problem one by one. Yeah. So to the left of Z. To the left of Z means what? Probability of Z is less than minus 1.78. So my minus means our interval start. What is the range of the Z here?
Minus
Minus
infinity.
infinity.
Minus infinity. Probability range is also the normal distribution range is start with minus infinity to plus infinity. So I know the end limit.
Right.
So my starting limit is minus infinity. So minus infinity minus 1.782 pi of Z into dz.
Yes.
Okay, this I can write here, split into area symmetric properties. Make use the symmetric property. I can split into two values because minus infinity 0. I know the value because probability divided into the area divided into two parts.
And one more thing, what is pi z? It is a standard normal value.
Yes, exactly.
Because here is a new notation.
Yeah.
So that's why we can say that is pi z is a standard normal.
Standard normal variant. So that is why if both problems are taking the same notation, student may be confused. In that case, I am taking the different notations here. So standardly we are in the textbook also we use these notations most probably.
Right.
Okay. So pi z is minus into 0 is the limit. Then minus. So minus of what is the variant? Minus 1 to 0.
Right.
So total area this to this one subtracting this value, then I will get the total value. So left to the Z.
Here minus infinity to 0 means 0.5.
0.5.
Right.
So 0.5 minus this value.
This value,
This part value.
This part
so then we'll get how much area occupied by the left of the Z.
Yes.
That is a one case.
Even minus 1.78 0 to converted to 0 to 1.78.
Yes.
That area
So
is available only positive.
Yeah. Why we can consider that means next I will explain that one only. What Dr. Ramesh is asking this question here, I will explain the next step because I convert that like this only.
Yes.
Okay. So here 0.5 we know the total area.
Yes.
So here minus 1.2 by symmetry this we can change 0 to 1.78 also.
Yes.
Okay. So I apply the symmetric property only but from table 0.5 minus 0.4625 is equal to 0.0. This is the area.
Right. Yes.
This area we need to up to this one is 0 to
Minus infinity to 0.
minus infinity to 0 is this value.
0.5.
0. I will find out this value already 0.5 minus 0 to here 0 to this value. If we subtract total area then this shaded area becomes left to the Z part.
Yes.
So what is the Z part here? 0.03, it's a very small part here.
Right.
So this is one example. First question. If I ask the second question, to the right, one is earlier, one is left. If they are asking the right, in that case, Z is equal to what is the Z value? Z is equal to probability of Z is greater than minus 1.45.
Right.
Okay. So already standard form. So now I can calculate my integral values are what? Lower limit. My lower limit value is minus 1.45 to 1.45 to infinity.
Positive. Right.
Positive. So in that case, what I am doing, same argument I can apply here. Earlier I can subtract, but can adding total value because I can show in curve, normal curve. Okay. So my first I can split into two limits here. According to Riemann integral property, we can split into n number of times.
Yes.
So two continuous limits we can consider. In that case, minus 1.45 to 0 is the first limit plus
Then 0 to remaining.
0 to remaining pi of Z. So we know that 0 to infinity value
That is 0.5.
0.5. Okay na. So then you can check this.
Again, you apply the
I can apply the symmetry. Earlier it is a minus is a denominator. So denominator value is converted to numerator also. According we have the symmetric property. By applying the symmetric property, 0 to my integral values is 0 to 1.45 pi of Z into dz plus 0.5 by making use of symmetric property. So my total value is 0.4265 from table.
The table value.
Table plus 0.5. Adding this total. So here to my value I would like to calculate here to here.
Okay.
Total. Shaded area. This is a shaded area.
Right.
So normal distribution. Okay. So the normal distribution okay, mean of the normal distribution is mu. Very beginning we say mean of the normal distribution is mu and standard variance is equal to sigma square. Okay, so then already we either use the moment generating function or else we can use the another methods. We can calculate we should find the area and mean and variance of the distribution. So our mean of the normal distribution is mu and variance of the distribution is sigma square.
These are nothing but parameters of the normal distribution.
Parameters.
Whatever
So that is why
sometimes.
a student is need to understand and able to always we can remember these two parameters.
Yeah. These are nothing but statistical measures. Measures center tendency and dispersion.
Yes,
The
yes.
mean
That
is
is why-
mu. So
Okay.
now let us continue
Yeah,
another
I'll
problem. sir.
continue this. Okay, after that we get how much percentage here? 0.9265.
Right. 93% about
93.
chances are there.
So almost 92% is a chance to get this value. Okay. So another approximations are, this is very important here.
So this is one of the most application of normal distribution.
Yes.
Whenever size n is very large value.
In that case, a
you can
student is
use-
confused how to identify these things.
Yes.
That is why we are very beginning I given the two important tasks. What is the important topics here? One is limiting cases.
Yes.
So what limiting cases? Two limiting cases. What is the limiting cases? First one is
Binomial.
another one is
Poisson.
So limiting case of normal distribution.
These two distributions are discrete distributions. If
Yeah.
the sample size is very high, generally
increasing.
we can assume that follows the normal distribution.
Yes,
How
yes,
we can assume that follows the normal distribution? Just you can explain.
Yes, sir. So there are normal approximation to the binomial distribution application. Here I am going to explain one example here. So applications of limiting case of the binomial distribution applications. Okay. So first one is there are 100 true or false questions.
Yes.
Generally what is earlier very beginning Sampath sir explained one is application part here. Generally we have to normalize. So sometimes we are getting the set wise examination test.
Right.
So we need to normalize the data. In that case also we apply this normal distribution techniques.
Yes.
So set of people, for example group 1, group 2, group 1 is exam is conducted.
For different session, different
sets.
question papers are there.
People are getting the first set number 1, set number 2, set number 3, set number 4.
Yes.
Standard of the question paper is different.
Different.
For each session.
Even the scores should be percentage converted to only
Yeah.
by using normalization.
That is called as a normalization. We can apply some normalization
Percentile.
factors.
Yes.
Okay. So here also we can apply some normalization. So that means we have to use some correct measurement. We can take some correction factors here to convert the data into this appropriate model.
For
So in that
converting this, the sample size should be the very high. At the same time, probability should be very small.
Very small.
So this is the basic fundamental principle for converting discrete distributions to the normal distribution.
yes. So in that example, I am going to explain one example in that case also. There are 100 true or false questions. What is the probability that guesswork will be yield? So students are behave that sometimes chance I'll choose this one. Action. What is the chance of getting that marks, scoring the marks? So in that case, first by exactly 45 correct answers out of 100.
Yes.
So second bit is I am asking 45 to 55 correct answers, both inclusive, means including 45 also, including 55 also. In that case we are taking less than or equal.
Less than or equal.
Okay. Less than 40 correct answers, chance.
Yes.
So here number of 100, that means number is big number. Okay, let x be a number of correct answers. It's a random variable. My random variable is number of correct answers. Since x follows here, chance means equal chance. P is equal to 1 by 2, Q is equal to 1 by 2. Guessing only. Equal chance.
Yes.
Okay, guessing means either it may be correct, either it may be wrong. Chance is what is the chance? 1 by 2.
There is no link between those things, so we can say discrete first.
Discrete function. This is a discrete function. Now it's a discrete function. The discrete function we should convert it into continuous.
Continuous.
Because sample size is very high.
Very high. In that case, let x be a random variable of correct answers since x follows binomial distribution. So binomial distribution n comma p. N is a number of trials and p is a probability of success. Okay. Here that is generally we know that p is known as a mean. Okay, n comma mean. Mean of the binomial distribution is np. Okay, in that case b of n comma 100 comma 1 by 2.
Yes.
Therefore, my mean of the binomial distribution is equal to expectation of x is equal to NP.
Yes.
Okay. Now I can substitute my n value is 100 and I can substitute these values in this function in this equation. I get
50.
mean value. My mean value mu is equal to 50.
50.
50.
Yes.
So then variance, already we know the variance of the binomial distribution. What is the variance of the binomial distribution?
We know NPQ.
So
Okay.
NPQ is equal to 100 into n is 100 and PQ are having the same chance.
Yes.
That means 1 by 2 into 1 by 2.
Yes.
So I can simplify this 25 variance. So now I get the standard deviation. I want to standard deviation. How to get the standard deviation? Square root of variance. So square root of 25 is equal to sigma. Sigma is equal to 5.
5.
So my first question is probability that guesswork will be yield exactly 45 correct answers is.
Yes.
What is that? Exact means what? Equal.
X equal to 45.
X equal to 45.
Probability of X
So
equal to
probability of X is equal to 45. Then I can go for correction factor because this is this interval is I can convert it into continuous factors.
Okay, right.
So what is the
So,
reason how to convert? What is the purpose
because
of this?
it is earlier one is discrete.
Yeah.
Now it is a correction is what is that case? Limiting case. Which limiting case we can consider here? Binomial distribution. Okay, binomial case is in that case that data is converted into continuous factor.
system.
They can adding 1 by 2 0 point correction factor 0.5 is adding in lower limit, subtracting lower limit and adding from the upper limit.
Yes. Yes.
Yeah. Here my lower value is 45 minus 0.5. This is a correction factor.
Okay.
Yes.
By making use of this equation is converted into continuous manner. Okay. Less than or equal to x is less than or equal to 45 plus 0.5. Okay.
Yes.
My values are where earlier it is what is the line x lies between where to where 44.5 to 45.5. So now standard now these data I can convert into standard normal variance.
Standardization.
Just general
Yes,
procedure.
yes,
What is
yes.
that? 44.5 minus my mean value is what? Mu value is 50 by standard deviation. Is less than or equal to z is less than or equal to 44.5 minus same. Okay. Then my normal values are like my making use of table I got this value. Very less chance to expecting that answer. Very less value. That is 0.0483.
Yes.
Okay. Now coming to second bit is probability that guesswork will be yield 45 to 55 correct answers, both inclusive. Inclusive means we can adding less than or equal to.
Yes.
Okay. So again we can adding the correction factor. What is our correction factor here? 45.0.5. So now 45 minus 0.5 is less than or equal to x is less than or equal to 55 plus 0.5.
Yes.
Then after simplifying these two, we'll get this one. What is that? Probability of 44.5 is less than or equal to x is less than or equal to 55.5.
Now again convert into Z scale.
Again convert into Z.
scale.
So after getting the Z, I'll get these values.
Yes.
What is the value? The range of the distribution is like this. Okay. So then we'll get what is the chance here? Chance is 72%.
Right.
If the student will get appropriate answer, the chance probability of that guesswork will be yield 45 to 55 correct answers, both inclusive is 0.7286%.
Right. 72.86.
Yeah, 72 point. If we convert it into percentage, it becomes 72.86. Okay. Another one is one more question is asking here. One more bit. Probability that the guesswork will be yield less than 40 correct answers.
Right.
So in that case, what is that probability? Probability of x less than 40. X less than 40. Probability of z is, so after converting the standard normal variate, this is that value is already correction. I use the correction factor. Then it becomes what? 40 minus 45. Then minus this one is equal to
Z less than
z
minus
less than
2.8.
minus 2.38.
Yeah. Again convert into
Again
symmetric
converted, we
property.
can use the symmetric property and I'll get this value, that is 0.0087. Okay, very less value.
Yes.
Okay, so this is the few examples which is related to this application area related problems. One is a normal curve related problem, variate problems, and Z is given to us. Sometimes that guessing questions are limiting case problems. So this is it today's sessions here.
Yeah. Thank you, professors. Thank you one and all once again.
Thank you.
Thank you.
Wonderful.
Thank you.
Have a nice day, wonderful day.
Thank you.